Good morning, Michaela. Again, I apologize. My voice is a little scratchy. So if I clear my throat a few times, I apologize. Or if I sound a little bit weird. So you've been working pretty hard. Thank you. Hopefully it's kind of going okay. Watching the videos, having them taped for a little bit, rewatching them, looking at other things. I'm very sorry. It would get really annoying every time if we were doing limits to have to go to Desmos and plug the equation in Desmos and know what's going on. I'm going to use Desmos in a minute here to show you something. However, you should not have to plug in Desmos all the time. And it has to do with being continuous or discontinuous. And it's kind of funny because a graph is actually probably only discontinuous at one point. So let me share my Desmos screen. I think I have a Desmos screen somewhere. Okay. So if we look at Desmos here, and let me make this one, there we go. So we're looking at Desmos. The red graph is showing right now, which you can see the red graph is the f of x squared, the x squared one right here, yep. No matter where I click on this graph, that little red dot is going to continuously be there. There is no gap, no space, no nothing in this first function. Desmos is probably going to hate me when I do this, but this graph would be continuous. Since that graph is continuous, there are no issues, there are no gaps, there is nothing in here that would cause us any issues. So if I want to plug in 3.716, I know that at 3.716, the answer is 2.377. That technically would mean the limit is also getting close to 2.377. So the other day when you were doing your problems, Michaela, like we had trouble because we were having trouble getting close to like -1 or something like that. That's not a good answer for this one. So let's do 2. Look at right here. I didn't mean to. I clicked right on 2. It looks like when I'm getting close to 2, I'm getting close to -4. You can see that in that ordered pair there right here. Let me see if I can try to pause it and show. Yeah, so since we're getting close to 2, I'm actually at -4. But if I would slide right here, notice I'm close to 2. I'm close to -4. If I would slide right here, you can't see it now, so let me do this again. I'm close to 2. There we go. I'm close to 2. I'm close to -4. But since this graph is continuous, instead of having to go to Desmos and look at Desmos, let's say I didn't want to look at Desmos. I didn't want to look at the graph. What number did I say we should be getting close to? 2. So if I look at this top equation and instead plug in 2 squared minus 2 times 2 minus 4. Oh, wait a minute again. When I was getting close to 2, I was getting close to -4. Since 2 is not a discontinuity, is technically what I'm going to call it. Since the graph is not discontinuous at 2, I can just plug it in and I get -4. Tells me the exact answer. I'm going to delete that graph. I'm going to turn this graph on, but I'm going to have to zoom my graph out a little bit. And I would like to zoom it out. There we go. Those gray marks I like a lot better now. And I'm going to do one other thing though. I would like the x-axis to go to about -20. I would like the x-axis to go to about -20. And I would like the y-axis to go to about -20. 40. All right, so this would be one where I'm going to type it in for just a minute, but we actually would have an asymptote, which we're going to talk about in a couple of days too, at x equals -5, excuse me. That purple line that goes up and down, if you notice this blue line gets closer and closer and closer, but is never going to touch or cross it. So this would actually have a discontinuity. This blue graph has a discontinuity at one place. The one place this graph has a discontinuity is -5. And I'll tell you why as well. If we would plug -5 in, we would get a 0 in the denominator. That's why we know where that -5 is a discontinuity. But once again, I could ask almost anything. It does not look like this is going to, this one will be a nice number. It looks like. What if I ask you, what is the limit as we approach -3? Well, if you notice, -1, -2, -3, it looks like -3 is going to be about right here. It looks like as it go like this. Oh, do you see how actually at -3, this graph is not discontinuous? It has a dot right there. It has a blue solid dot. The other day when it was discontinuous, there was that open dot there, correct? So since it is continuous at -3, over here on this side, I could just, I'm going to copy it right now. I could just instead plug in -3. Please be careful on Desmos. Sometimes when you're plugging in numbers, it helps to put negative numbers in parentheses. And I'm sorry for kind of going slow here. Oh, look at that. When I plugged in -3, I got -4. And if we look at the graph over here again, it is not discontinuous at -3 because I have that solid dot. So since it's not discontinuous, I can plug in -3. So let's find the limit at, I don't know, look at -15. Does it look like it is discontinuous there? Or does it look like I would get a solid dot, open dot there? No, it looks like it would be solid the whole time. -15, plug in -15. Oh, it looks like my limit would be -22. And notice again, I'm pretty close to -15. I'm pretty close to -22. I'm pretty close to 15, -15. I'm pretty close to -22. But I don't have to use a graph to do that because since this graph is discontinuous, my fault. Since this graph is continuous at -15, I can just plug in -15 and get -22. The times it becomes an issue is if I would be asked to plug in -5. And here's something that's kind of funny. If I look here at -5, once again, you do not see a graph there. It wouldn't matter if I scrolled up forever or scrolled down forever. You're not going to see a graph at -5. I don't know why I did what I just did over here. So there we go. If I would plug in -5, and this is something you can do anyway, and then you just realize, oh, if I plug in -5, it tells me undefined. And therefore, this graph is discontinuous at -5. If the graph is discontinuous at -5, there's a couple things, Michaela, right now I'm going to tell you to do. Number one, if it says discontinuous, what you're going to try to do is factor this problem. And the only thing you can factor is the top. So would you think for a minute, how could you factor the top? So pause the video, factor the top. And I'm sorry, obviously, it took a little bit of time for me to type that in. So you probably paused and did it. Hopefully, whatever way you did it. Now, I would like you, and it's kind of convenient that they made both of these blue graphs. Right now, it doesn't really look like these two graphs are the same. But if I zoom way out, minus the fact that crazy asymptote place, what happens is I go really far to the left and really far to the right about this graph and this graph. They actually look the same. It's just this graph doesn't have that crazy zigzag at 5. This graph does. Remember, I was asking you to find the limit at -5. Now, the truth of the matter is right now, if I go to -5, it's going to still say no solution. It's still going to say undefined. But that's because if you notice, this binomial is the same as this binomial. And since that is the case, those could actually be deleted. Wait, the graph x minus 4 is the same as this graph right here. So even though this first one is oh, Michaela, you know what? I'm just realizing something. Even though this first one is undefined at negative, I just saw something. Hold on just a minute. Since this first one is undefined at -5, this one should also be undefined at -5. My fault. I'll fix it in a minute. Oh man, all my zooming around. This actually, and I apologize, you might be like, Miss Jebs, this is not how I factored it. I knew I wanted this binomial to cancel with this binomial. So I apologize. It's going to change the graph just a tiny bit. That should change to a plus. Okay. And now you notice those two graphs are the same. And if I take this away and that away, they are the same. Okay. Real quick, what's going to happen on this one at -5? Open dot, undefined. That's why it looked the same even with the asymptote. What's going to happen with this one at -5? Close dot, -9. That actually means your limit is going to be -9. So I apologize again. I'll explain why this goes on. Okay. And again, sorry for the wrong factoring. The problem would have probably said, find the limit here. And then I can't necessarily right now, but underneath here, it would have said as X is approaching -5. Well, anytime it says limit, you actually kind of can think, like I said, about typing in -5. So let's type in -5 here. And here. And here. Right? I like to put those parentheses in there so we can see that at -5. At -5, it is undefined. So let's think about the original equation again, and I apologize that I had factored it wrong, or first had it set up to be factored wrong. We're going to change this to a plus X, my fault. We know that this should be undefined at -5. So we're going to actually factor the top. Once you factor the top, you should notice that a set of binomials cancels. I don't have the app open where I can cross this off, but since it cancels, we would get X minus 4. And oh my goodness, look at that. Yes, X minus 4 over here. But that means, remember, I was supposed to plug in -5. Can you plug in -5 to this problem and not have it say undefined like you did when you plugged in -5 up here? Yep, when you plug in -5, you get -9. And remember, originally when I was looking at all this, I kind of had that dot there and it said -9. So I apologize for the mistake. When we have an asymptote, something else comes up, which is why I think I had that one on there. When you have an asymptote, things will not cancel. And if things do not cancel, that's a whole nother video I need to kind of line up and talk to you about. So I apologize, that was not supposed to show up. But on that worksheet, Michaela, I know the other day you did it, you plugged it in, you went on Desmos and did it. But I want you to see if you can get the same answers by looking at the graph, deciding whether it is continuous or discontinuous. Remember, if it's just an equation like this, that graph is continuous. No matter where I would go on this red curve, it's going to be continuous. And so since anywhere I am on that red curve, it is continuous. That means any number I would give you for this, I would plug in. My apologies for the one before. X squared minus 5x minus 6 plus 6 plus 6. And then x plus, nope, x minus 3. Okay, look at this one. Is this graph continuous or discontinuous? It is discontinuous because there is a fraction. But the only place it is discontinuous is where the denominator would be 0. The denominator would be 0 here when x equals 3. Because again, remember our binomials, like when we were solving binomials, if I saw x minus 3, the answer was positive 3 because we had to flip the sign of this. So the only place this is discontinuous is 3. So if I ask you what's the limit of this graph as you're approaching 8, just plug 8 in to your x's and you'll have your limit. But if I ask you to plug in 3, it's probably going to say undefined. And that's when you're going to need to factor and see if things cancel. If things cancel them out, plug 3 into the reduced answer. That would be your limit. Okay. So I know this video had a little bit of that mistake because I had a plus when it should have been minus. Hopefully you kind of figured that out. Hopefully the explaining again helped out a little bit. Watch the video, rework on the worksheet, come check in with me. And tomorrow, I'd like you to come to class tomorrow. That's Friday the 8th. On Friday the 8th, come to class. And we can try to talk a little bit at the beginning of class while the other kids might be working on something. I'm not sure, but I'm going to try to have them work on something at the beginning of class tomorrow. All right. So again, I apologize for making that one mistake of how it was my fault typed in at first, but hopefully it still made some sense after I made those changes. Let me know if you have questions anytime. Let me know if you have questions. Okay.